Welcome back to my YouTube channel. Today I'm going to talk about a very interesting topic, the introduction of a very interesting topic, which is graph of polynomial. So I would advise you, if you're not subscribed to my YouTube channel, please do subscribe so that you can get the latest video notification once I post and make some. So we are going to talk about graph of polynomials. Graph of polynomials, or the other way you can call them cubic functions. Cubic functions or graph of polynomials. We're going to look at what is consists under graph of polynomial, what you should know, and how you're going to answer questions under graph of polynomial. So what we should know under graph of polynomial is that graph of polynomials enable us to find approximate solutions to a wide range of equations, many of which are impossible to solve, impossible to solve by conventional means. What are they simply telling us? In graph of polynomial, we are going to encounter equations that you cannot just solve by any conventional means, but you need to approximate them. In order for you to get at least an accurate answer. So we are saying that when working out equations involving graph of polynomials, it is very important to take note of the following. So when you are dealing with graph of polynomial, it is very important to take note of the following. What are those? The following. A, we are simply saying tangent to a curve. Tangent to a curve is very important. If you are going to answer this question in your examination and get the full 12 marks, you are supposed to understand what tangent of a curve is all about and how do I draw this tangent of the curve. So we are saying that this is a straight line. Keep in mind, it's a straight line drawn to touch the curve at only one point. Let's say that this is my graph of polynomial right there, and I'm told that this is my y-axis and this is my x-axis, and I've drawn my curve, which is giving me something like this. Okay, graph of polynomial, we are going to encounter graphs like in this format. Okay, these are the forms of graphs you are going to find in graph of polynomial. If you draw a tangent touching at one point, it will be a tangent. Let's say this is a point there. Okay, the tangent is a straight line which only touches at a single point of a curve. So this is my tangent. This is what we call tangent. Okay, it is only touching at a single point of a curve, which of course, if I get my coordinates, it will be y here and the x there. So meaning that this point is just x comma y. It is only touching at a single point. That is what a tangent is. Why is a tangent important? The tangent is going to help us to be able to find the gradient of the curve. So if you don't know the tangent, therefore it means that even finding the gradient of the curve, it will be difficult because you need this point and other points inside the curve that will help you to find the gradient. So now let's talk about the gradient B. Gradient of the curve at a point. Okay, what is the gradient? We have been doing gradient in our previous video about linear programming. So if you have been following my videos on YouTube, you come across of what a gradient is all about and how you use the gradient. Of course, again we are repeating it here. We are saying that the gradient of a curve keeps on changing. So gradient is never constant. It keeps on changing at each point along its path. That's what you need to know about the gradient. Hence, the gradient of the curve at a point is only achieved by finding, okay, this is the key, by finding the gradient of its tangent. The gradient of its tangent, as we talked. So by finding the gradient of its tangent at that particular point after drawing the tangent. So here is my tangent. So after you draw this tangent, you can be able to find the gradient of this tangent by simply using this point which you have been given here, which is x comma y, and also you're going to have your graph which will demarcated into several boxes. Graph paper, okay? Your graph paper will be divided into several boxes and you draw your tangent in this manner. And this is your curve and your tangent will cut there. So for me to be able to find another point, it should be inside the curve here. So I'm going to look at where the two lines, like you see this box, okay, and this box is cutting here where the tangent is passing. So I'm going to get this point which is here and this point which is there. So meaning like if here it was 3 and here it was 5, meaning the second point will be 3, 5. So I have x, y and 3, 5 as my points to be able to find the gradient. Hence, this is very important because once you know the 2 points, therefore now you can be able to find the gradient by using the formula. Gradient is equal to distance in y coordinates divided by distance in x coordinates. Or you can write as gradient is equal to y2 minus y1 over x2 minus x1. So you can use this formula as the formula for gradient. Remember, for you to be able to find what my y2 and x2 is, you need to use the tangent to choose any 2 points on the tangent and use the formula, this one. So the points should be, we are going to have x, y, okay, x, y, and like we have said here, 3, 5, it is inside the curve. It is inside the curve, so I'm going to use 3, 5 as my second. So I can use 3, 5. These 2 points will enable me to find what the gradient is by naming this as my x1, y1, x2, y2, and just replace on the formula there and you get your answer accurately. So the tangent helps us to find the gradient, and the gradient now will help us to find any kind of equation that we are told to find. Hence, these two things are very important. When you know them, therefore you shall have no problems. And therefore now, when you know the gradient, you should also be aware that under graph of polynomial, they are going to ask you about finding the area under the curve, which is important. Finding the area under the curve, because the area under the curve, once you know how to do it, you face this also in calculus. Okay, in calculus also you are going to face this on how you should find the area under the curve. So when you are familiar with it, then you have less difficulties as you progress with your studies. Now, let's see what area under the curve consists. At times, equations will be asked involving finding the area. Okay, at times equations will be asked involving finding the area. Okay, bounded by the curve and other boundaries. Okay, bounded by the what? Bounded by the curve and other boundaries. Such cases, 2 methods. Okay, how many methods? 2 methods may be used to achieve this. Number 1 method, we are saying by counting the squares. Okay, by counting the squares is my number 1 method, or by trapezium rule, which is, this is the rule of course for trapezium. This is a rule for trapezium which states that area is equal to half, open brackets, a plus b cross bracket times h, which is the height. You can use this formula, or by counting the squares, you'll get your answer as accurate as possible. Since this often involves estimation, any square which, okay, if you're going to use the square, by counting the square, you should know this point here, okay? Because we are dealing with graph of polynomial, which is of course estimating the answer. We are just approximately getting the answer. Because you cannot, it's very impossible to to get an accurate answer under graph of polynomial. So we are saying that just estimating. So when you have to find the area by counting the squares, what you should know is that often involves estimation. Any square, okay, any square which is half or more, okay, which is half or more, is rounded off and counted as full square. What are we simply saying here? Let's say that this is my graph here, okay? Let's say this is my graph here and I have a curve in this format. Okay, I have a curve in this format. And we are told that this curve is on the graph paper. I'm sure you know what the graph paper is all about. And this is my graph paper, as you can see. I've drawn my curve on the graph paper. We are saying that if you are going to use the counting of the squares under the area of the curve, look at this box which is here. This is a complete square. This is a complete square. So this square we count it as 1. Okay? But when you look at this square which is here, this one is not a square, but it's half of the square. So this half of the square, we cannot count it, but we get this half plus another half. You can see there's another half here. This half plus this half, which is going to give us a 1 square. So we are saying that if I have this half which is here and this half which is there, when I add them, I'm going to have a complete square. Okay, this half and this half which is here, when I add them, I'm going to get a complete square. So you are going to count the complete square that will make your area. So in this case, we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus these two halves, which will give me 11 units squared as my area. So that is what we mean by counting the square when you don't want to use the trapezium formula. We shall see more of this in the given examples on how we solve and how we draw the graph and sketch. So now let's look at a very simple example consisting of all this I'm talking about. So we shall start tackling these questions, these major important topics we have talked of: tangent, gradient, and the area on the given examples. Please don't miss my YouTube videos because they are going to explain more about it. So let's look at the first example. Answer this question, enter this part of the question on a sheet of graph paper. The values of x and y are connected by the equation, this equation. So this equation is very, very important. Don't ignore it. Y is equal to x, open bracket, x squared minus 4, close brackets. Some corresponding values of x and y are given in the table below. So in statistics, you are going to learn that this is grouped data. And if you know it now in graph of polynomial, then you are not going to have problems when it comes to finding the standard deviation under statistics, also finding the curve under statistics by sketching the curve, because you are going to have similar problems like this. So now, the question is saying that x values will be given, which is -3, -2, -1, 0, 1, 2, 3. And when the y values we have been told -15, this is r, we don't know here, this is r, 3, 0, -3, 0, 15. The first question is calculate the value of r. So we need to calculate the value of r. Then we will place there and we can be able to sketch our graph. So today I'm just going to show you how to calculate the value of r and also how to sketch it, and we'll be done for today. Then the next video will show you on how to answer the question using the curve there. Again, using the equation and also more of it. So now let's see how we can answer the question. Calculate the value of r. So how do I find my r? It is very simple. Let's do the solution on my next board. Okay. So we do the solution on my mixed board, and you'll be able to see that this work is very simple and very easy. You can easily pass your exams with no difficulties, because the questions that you are learning with me are the same questions you are going to find in the exam, only that they will change one or two things, but there will be one way. So we are told that we should find, okay, so let's say solution for my first equation. Okay, find the value of r. That is the question. We need to find the value of r. So how do I find the value of r? It's very simple. We know the equation that they have given us is y. Okay, we have y is equal to, which is x squared minus 4. So having known this equation, you need to know what are the coordinates for x. Okay, the coordinates for x here, you can see you have given -2, r. So we are told that this is -2, r. We need to find what r is. So the best way you can find r is by replacing r. We know already that this is the y and this is my x. So we need to find what y is, and that will be our r, by simply replacing what my x is on the equation. So it will be y is equal to, what is my x is -2. -2 multiplied by negative 2 squared minus 4. Okay? So it means that my question is y is equal to negative 2, open brackets. What is negative 2 to the power 2? It means that it is positive 4 minus 4. Okay? 4 minus 4, it is 0. So y is equal to negative 2 multiplied by 0, which will give me y is equal to 0. So my value, therefore, the value of r is equal to 0. Okay? So when the value of r is equal to 0 there, therefore now I can plot my graph with less difficulties. No problems at all. So how do I plot the graph? Here's a sketch. As we did it in linear programming, so you should finish this work by plotting on the graph. So we're saying that, number 2, using a scale of 2 cm to represent 1 unit on the x-axis for this given scale, which is there, which is negative 3. On the x-axis, it means that I should use 2 cm on the x-axis to represent 1 unit. So it will be 1, 2, 3 on the x-axis. And then on the negative, it will also be negative 1, negative 2, negative 3. That's where I will end. And 2 cm to represent 10 units on the y-axis for this scale, which is here. So this scale simply means that on the y-axis, on the positive side, I'm going to use 10 units, which is 10, 20. And then on the negative side, 2 cm to represent 20 units, so it will be negative 10 and negative 20. And therefore, they are telling me that I should draw the graph of this, which is going to be very simple because we already know what my value for y is, for r is, which is 0. So now you can draw the graph with less difficulties. So we shall look at how we should draw the next graph with no problems in my next video. So please do subscribe to my YouTube channel so that when I post this video, you'll be able to get the notification. As for now, we shall end here, and God bless.